So for the second part of this assignment, you want to start off just by looking up, doing some research about the kind of expenses you'll be facing in retirement, and write a brief summary of those here. And the goal of that is to help you start thinking about how much money you would like to have saved. So for number 2, based on that research, just state a numerical value amount of how much you would like to have saved when you retire. And you would put that here. I've just made up a value here, but you would put in something based off of your research. And then how many years do you plan to contribute to your retirement account? And this is, if you plan to retire in 30 years, you would write 30. If you're going to retire in 25 years, you would write 25, and so on. So how many more years are you going to work and contribute to your retirement account along the way? And what we're going to be doing in this document then is figuring out how much you need to put aside each year in order to reach that goal you had that you stated here in number 2 of how much you want to have when you retire. And based off your last name, just pick an interest rate that falls within this range. Make sure you write it as a decimal. You got to shift the decimal point 2 spots to the left to convert that percentage to a decimal. And we're just going to assume you always earn that same interest rate for all those years that you're saving. Now, how many times is your interest going to be compounded during the year? And compound interest gains money faster, but this is also how many times you're going to contribute to your retirement fund. So you're putting money in for 25 years, in this example here that I'm doing. If I picked semi-annually, that means each of those 25 years I'm putting money in 2 times into my account. If it's 52, that means every single week I'm putting money into my account. And in this problem, we're going to figure out how much money you need to put in each of these contributions in order to reach your goal that you stated in number 2. So I picked 12 for this video. That means once a month I'm going to put money into my retirement account. We're also saying that the interest is compounded once a month as well. So number 6 here, the interest rate, really simple formula to figure it out. You take your interest rate that you chose, up here number 4, and you divide it by how many times a year the interest is being compounded. So I would do 0.055 divided by 12, and I would get that solution. Now, this formula, you just it's listed. This is the one you use. It just needs to be typed into your calculator correctly. Make sure you're following the order of operations. You can do it bit by bit, and that's what I kind of suggest. Let me kind of show what I mean by that. So the top part says it's F times I. So ignoring the bottom, let me just do F times I. So F was my value that I chose, which was 750,000. And my I value was this 0.00458. And I'm just going to type, I'll just type that in, 0.00458. Oops, I had too many decimal spots. Okay. So this is the top part of this formula. Now this bottom part has a 1 plus I. So let me just write that down. I've done my top 1 plus I. Well, my I is 0.00448. So I'm going to do 1 plus that equals 1 plus 458. 458. Yeah, all right. So that's my 1 plus I part. Now my N times T, let me go back and refresh. My N is 12 times a month I'm contributing. T is 25 years. So here I'm going to do my N times my T. And so that is going to be 25. All right, my N was 12 and my T was 25. 12 times 25, so 300. So this whole part, 1 plus I to that exponent, I can do now here. It's my answer there, 1.00458 raised to the 300th power. And I'll just use cell reference here, but you could type into the 300. I'll go ahead and type it in, 1.00458 to the 300th power. And that's the value you get for this first part. And then it says to do -1. So I'm going to take that answer, 2.93875 and do -1. And if I was actually working this on my own, I would use cell reference to make sure I don't type anything incorrectly. I can do A4 -1 and you get that same answer. All right, so that's the whole, this is the bottom now. So I have the top part and I have the bottom, and that's the fraction. I'm just going to do top divided by bottom. So with cell reference, I'm doing 3435 divided by the bottom. And if you don't have cell reference, you just type in these numbers. So 3435 divided by 2.93875. And you get 1168.86. Now my decimal is off by a few cents here because I did round. I didn't include that 3 in my calculations. I'm not going to be picky about a tiny decimal being off. If you follow these steps, you're going to be in the right ballpark, and that's what I'm looking for. So this answer here, this is our answer, the top divided by bottom. Let me just go ahead and write that here, the top divided by the bottom. That's your answer. And that's how much for my goal, for my example I made up here in this video, that's how much I would need to contribute each month, because I picked 12, for the next 25 years. If I put that much in the bank each month for 25 years, it will gain interest. It will gain at this interest rate. And at the end of those 25 years, I'll have that much money. All right. And so this is just asking how much was my total contributions. If I put this much in, and it tells you the formula, the total contributions is how much you put in times the number of times a year times the number of years. So I'm putting in 1168.86. I'm doing that 12 times a year for 25 years. I would put in $350,000. So that's how much of my money was put into the bank. And over time, over 25 years, it grew in interest to reach $750,000. And that is just based off the math, the facts. This formula, which is mathematically accurate, if you put this much money in every month for that many years and just let it grow with interest, over time you will it will grow to precisely $750,000 if you let it sit there in the bank and keep getting that same interest rate. So that's the power of compound interest, the power of saving. This is less than half of what my goal was, and the rest of the money just grew from interest. And so you'll talk about that a little bit in the final 2 questions about how money can grow over time through compound interest, and you'll end up having a lot more money in your account than the actual amount you put in.